Hello and welcome again as we look at yet another multiple choice question for IB Chemistry. This one dealing with topic 10, and actually this question also provides a very good exemplar of why you should be familiar with your IB Chemistry guide. So let's pause here and go into the chemistry guide and take a closer look.
And here under section 10.2 of the IB Chemistry Guide for First Assessment in 2016, which is the same guide that applies for the 2021 exams, halogenoalkanes under section 10.2 Functional Group Chemistry, it says halogenoalkanes are more reactive than alkanes. They can undergo nucleophilic substitution reactions. And it says a nucleophile is an electron-rich species containing a lone pair that it donates to an electron-deficient carbon. And then here under the application and skills section it says writing the equation for the substitution reactions of halogenoalkanes with aqueous sodium hydroxide. Of course, this being the SL section, it says that the mechanism of SN1 and SN2 and electrophilic substitution reactions not required. Of course, this is very much a part of the HL chemistry syllabus in section 20.
Of course, you should realize now that this question deals with the topic of nucleophilic substitution, a topic that's very much developed for HL students, and this particular question is unlikely to show itself in the HL exam. This particular question, of course, appeared in the SL examination. And a nucleophile is an entity that's going to have a lone pair of electrons. In HL chemistry, it's also referred to as a Lewis base or an electron pair donor. But here in the SL chemistry syllabus, it's an entity that's capable of donating its lone pair of electrons to an electron deficient species. That deficient species, of course, here is going to be C5H11, which is going to carry a positive charge as it's associated with I negative, and this very polar bond. This here would be lost, giving this positive center here with the carbon, which can then accept this lone pair of electrons. That is an example of a substitution because the halogen group leaves and the OH takes its place. It's a substitution. It's a nucleophilic substitution because this electron pair donor is attracted to a positive center, which is this C positive here. That positive center, it's being attracted to it. Nucleo, which refers to the positive part, and philic or philia, that attraction or association with. Nucleophilic substitution, a typical reaction of halogenoalkanes. And of course, for HL students, a very, very important topic for you, and you can learn a lot more about SN1 and SN2 reactions if you're an HL student by clicking on this playlist above. Answer for this question, of course, A.